Hello everyone, welcome to our first online science video. I wish I could be there in person to do this with you, but we're going to do the best we can with this. Will you please find your Will It Conduct paper and make sure that your name and number gets at the top of it. We are going to be testing a whole bunch of conductors and insulators. You should know a little bit about this because you've already completed your science folder quite a while ago, and then you've watched a video recently about this, and we're just going to wrap up current electricity with this experiment. Normally if we were in class I would be having you all do your own experiment with these supplies, but we'll just make this work like we're making everything else work. So it says it wants us to try out our conductivity tester. We're going to fill in the chart with some of the experiment stuff we're doing, but before we start that, I actually want to come down to this section right here that says write a definition for each word. I want you to think about this for a minute. What do you know about conductors and insulators? Think about those two words for a minute. Conductor and insulator. Hopefully you're trying to think. Remember, if you're just sitting there not processing it, that's not actually helping you learn it. So really try to think about it. What is a conductor and what is an insulator? I will give you a hint. One of these items allows electricity to pass through them, and one of them doesn't. So is a conductor one that does, or is an insulator one that does? The answer is a conductor does. So any type of material that allows electricity to pass through it is a conductor. So we're going to write that definition. Materials that allow electricity to flow through them easily. That word easily is pretty important because if electricity is strong enough, it can go through insulators, but it's going to more easily go through conductors. So a conductor is materials that allow electricity to flow through them easily. We put a couple dashes after that. We're actually not quite done with that, but I want to answer it after all the experiments. So come to insulator. Remember I told you that they were opposite. So if these are materials that allow electricity to flow through them easily, then an insulator would be, hopefully you fill in the blank there, an insulator would be materials that do not allow electricity to flow through them easily. That do not allow electricity to flow through them easily. I'm using a pen just so that you can see it a little bit better, but you should be using a pencil. So if you're not, go ahead and pause the video and switch to a pencil. All right, so now we know what a conductor is and what an insulator is. So remember, current electricity is the flow of electricity. In order to have a circuit, because you've done a couple activities on your own with circuits, remember you did the blobs purple paper by going online. So remember, you have to have 4 things in order for a circuit to be complete. You have to have a power source. In this case, we're going to use a battery as a power source. This battery is in a special case, just so that it's a little more safe for me to conduct the experiment. This is what the battery looks like outside of the case. So it's just a normal D-cell battery. You know, the most common batteries are actually AA or AAAs, but this is a D-cell battery, so it's a little stronger. And inside of every battery, hopefully you know this, there's acid inside of it. It's kind of like a liquid, and actually battery acid can be really dangerous to your skin and clothing. Your car runs on a battery. Do you think it's this size battery or smaller or larger? Hopefully you thought that through. It's larger. A car battery or truck battery is way larger. But anyway, yeah, so that's what batteries are made out of. And inside of this battery is the acid that's highly conductive. And batteries have this metal ends, right? They have the positive side that has the bump and the negative side that is just flat. So all batteries have a positive and a negative. Okay, so right now it's that same battery, but it's in this case. So this is going to act as my power source. I'm actually going to use this one. It's the same thing, but it has 2 ends. And you can see that on this one, it has on the edge little metal sides, and that's going to be so that I can use it without actually touching the battery at all. So it's kind of cool. Anyway, so power source. You have to have power source to complete a circuit. Another thing you have to complete a circuit is a way for the electricity to flow. You know, I can't just put this battery here and put this light bulb here and say, hey, go ahead, light up. Right? I have to have a way that the electricity can flow from the power source into the item I want to use the power for. So these are called wires, right? And this is these are called alligator clips. They kind of open like an alligator's mouth. So that's what they're called. But actually, I always say I want to do this, and maybe I'll actually do this today. But I would love to show you, if I were to cut one of these, what the inside of a wire looks like. So maybe we'll do that at the end of this for fun. I've never done it before. I've always said I wanted to, so you'll be the first class to get to have that. Anyway, inside of here, inside of this rubber-coated wire is little tiny thin metal wires or copper wires, and that's what has the electricity go from the metal end through all of the copper and steel maybe and into this other end. So right now, if I were to use the alligator clip and put it on both ends of the battery, oops, just a second, let me clip it on. So look, I'm clicking the metal to the metal. I'll hold that up a little bit closer to the camera for you to see. I'm clicking the metal right here to the end of the metal, and that is a complete circuit technically, because it's going around and around and around and around, and I'm kind of wasting the power of the battery because I'm not using it for anything. So it is a complete circuit because there's no gaps and it's flowing, but most often we don't just waste a battery like that. We actually use it to connect with something. So I'm going to show you this light bulb. This is another item you would maybe want for a circuit. You want to have something that you're using the power for, right? In most cases, it's going to be something that lights up or makes noise or will move, like if you have a remote control car, right? You're using the power for something. So in this case, we're going to use a light bulb. So I have three of the four things. I have a battery, wires, a light bulb, and the fourth thing, do you know what the fourth thing is? Think about electricity in your house right now, or in my house. What is happening? I guess you can't really see it because my lights are on, but in your house, you have circuits constantly running, and you have the option to turn them off. And do you know how you do that? One way is through a switch, and there are lots of different kinds of switches. You can have a switch where you push a button. You can have a switch where you turn something, like flip it off or on. You can have a switch where you actually twist something or slide. So like if I think about my phone, right, if it's locked and I go to open it, I have to slide across the top and put in a pin, that kind of stuff. So there's all sorts of different types of switches. This happens to be a slide switch actually, because I can take this little light bulb right here and I can slide it off of the metal onto the plastic, and that would make it so that it's not connecting to the metal. But if I can move it onto the metal, then I have metal of the light bulb touching metal of this little plate, and so I have the light bulb in order to work. So I have light bulb, battery, wires, and the switch is technically on there too. So I'm going to try and light it up. Remember, if I touch metal to metal, it should go right through. It's not going right through. Can you maybe try to predict why it isn't going through? Think about that. Hopefully you're figuring it out. I need to be able to make a complete circuit. Right now there's a gap. It's not touching from this metal to that metal. There's no circuit, or it's not going around at all. It has just stopped right here. There's a gap. So that's an incomplete circuit. Anytime you have a gap where electricity is not flowing through, that would be an incomplete circuit. So in order to complete it, I have a couple options. I could just pick up the battery as long as I'm careful and hold the plastic case. And I could touch the metal to metal, and it should light up the light bulb. Or I can use another wire. So let's try just touching it. I'll be really careful. Make sure it's all connected. Just try touching it. Oh, did you see that a little bit? I don't know if you could tell. Try it again. Yeah, it lights up a little. Oh, that's pretty cool. It seems to be really, really dull lit up. So what could I see how that completed the circuit? What could I do so that that's not as dull? I could add more batteries. I can add more power. If I add another battery to this mix, I have to be really careful. You've got to make a positive connect with a negative. So if I'm looking carefully at this battery, this is the positive. This is the positive side. So should I put positive by positive? No, that would repel it. So I need to put a negative touching that side. So this is the negative. And now they're touching metal to metal. Listen to that. So they're touching. And now, if you can see this, hopefully you can. And now I have two batteries, and that's great. And I'm going to use, I can't just touch the end to end, so I'm actually going to use the other wire. I have another yellow wire. And I'm going to connect this end of the battery. And I'm going to take this last end right here, and I'm going to touch this side of the light bulb. Right? And if I have a complete circuit, it should light up, and it should be brighter than what it was before because I have twice the amount of power. Oh, it didn't work at all. I love experiments like this where you're just trying to figure out what's going on. So I just double check it. Well, I've got my positive to negative. They're touching. That's still attached. It's going around. That's touching. Maybe I don't have my light bulb right where it's supposed to be. Yeah, I think the switch was off. There we go. Yeah, the light bulb had been twisted and it was off of this little metal plate right here. So I just twisted it back on. Remember, it's like a spin switch. And once I touch that, I try it again. Then it lights up quite brighter, if you can tell. I think what might be really fun is if I actually turn off my light so you can see how bright that is. This will be fun. Now I can't see it all, and you probably can't either, so I better be able to use that circuit to light it up. This will be really interesting. I actually think I need a little bit of a light on. I can't see anything. There. Now I can at least see something. Okay. Thanks for hanging in there with me. So you can't see this, but I have the end of the alligator clip, and I'm just going to touch that metal part again. See how bright that actually does light up? So it's when I let go, like when I remove it, it's incomplete, right? But when I touch it, then it is definitely a complete circuit because it lights up so bright. So I want you to think about that. The difference between having one battery, well, I'll switch it to just having one. Okay, so you can see that it lights up that much. And now I'm going to connect the batteries back together, and you can see how much brighter it is. It's twice as bright. Twice as much power. So we just wanted to make sure that we knew that this little circuit of ours is going to work, and now comes time for the experiment part. I love this part so much. We are going to take a whole bunch of items one by one, and I'm going to use, I better use this right now, but I'm going to use an alligator clip right here, and I'm going to attach other items. So I'll grab an item with this little clip, and then we're going to touch it to this metal part right here. And if it is a conductor, then electricity should flow through it and it should light up the light bulb. If it is not a conductor, then the electricity is not going to flow through it, and it would be called an insulator. So that's what the experiment is we're going to list one thing at a time and try each one, and we're going to have you make a prediction and see if you were correct or not. So when we do this next part, I really need you to be honest and do your best on it. The whole point is not to get all of them correct. The whole point is to learn something. So Ms. Fisher's not sitting here in the dark doing this experiment so you can just copy answers. I'm doing it so that you can engage in it and really try to think through what you feel like the answers might be, okay? So in the next video, we're going to do some testing of items, so make sure that you have a pencil ready and you have your honesty with you, and we'll do our best to make some predictions, okay?